Hello and welcome to the first session of our training series on foundational standards in aircraft system design and safety. I am Hadis Nagian, and in this series we'll take a focused look at ARP4754 and 4761, two key frameworks that define how civil aircraft systems are developed, validated, and certified. Whether you're an engineer, safety analyst, or aviation professional, this series will help you understand the principles behind safe and reliable system design in aviation. So, why are these standards so important? So, here's the deal. In aviation, having a functional system just isn't enough. You can't just say it works. That's not how this industry operates. Everything must prove one thing above all: safety. And I mean provable, measurable, certifiable safety. That's exactly where ARP4754 and 4761 come into play. Let's break it down. ARP4754 gives you the complete roadmap from top-level requirement down to final system verification. It's exactly your development backbone. Meanwhile, ARP4761 steps in with the safety side of things. Just think tools like FHA, FMEA, and FDA. These aren't just acronyms. They are the foundation of how we assess and demonstrate that the system is truly safe. And here's the point: these two aren't optional. They are the cornerstones of building systems that are not only certifiable, but also trusted by regulators, pilots, and passengers alike. If you are building for the sky, this is your playbook. Now let's take a closer look at ARP4754, the latest revision of the standard for aircraft and system development, officially released in 2023. This document builds upon the foundations of the original ARP4754 and adapts the framework to the increasing complexity of modern aircraft systems. So what exactly does ARP4754 bring to the table? Actually, it provides structured guidance for the entire development life cycle, including capturing and allocating requirements, defining system and item architecture, applying development assurance principle based on FDAL and IDAL, performing through validation and verification, planning for certification from day one, ensuring rigorous configuration and process assurance. And here's the key point. At the heart of ARP4754 lies development assurance. Let me repeat that. Development assurance is the cornerstone. It's all about making sure that any potential errors in requirements, design, or implementation are identified and mitigated proportionally to the level of risk they pose. Think of it like this. Not every failure has the same impact, but every failure matters. So, ARP4754 scales the rigor of the development process based on how severe the consequences of failure could be. And trust me, that's exactly what regulators want to see. When you walk into the certification audit and they know you are aligned with ARP4754, you are already halfway there. Now we are gonna talk about the value ARP4761 adds. ARP4761 complements ARP4754 by providing structured and practical methods to carry out the entire safety assessment process. This means it doesn't just tell you what to do. It guides you step by step through critical evaluations such as aircraft functional hazard assessment or AFHA, where we identify what could go wrong at the aircraft level, system functional hazard assessment or SFHA, zooming into a specific system to spot potential failures, and preliminary aircraft system safety assessment, or PSSA and PSSA, which helps us catch risk early in the design phase, and system safety assessment, or SSA, that is a deep dive into detailed system hazard and their mitigations. Each stage builds the previous one, sharpening our understanding of hazard and making sure the right controls are in the place. The goal is simple but crucial: to keep safety front and center from the very first concept all the way to the final product rollout. ARP4761 introduces several key tools to analyze and manage system safety. These include fault tree analysis, or FTA, failure mode and effect analysis, or FMEA, common mode analysis, or CMA, and other things. Each of these tools plays a unique role in identifying, understanding, and mitigating risks, and we will dive deeper into each one later. Then, how the two standards interact? ARP4754 and 4761 aren't standalone documents because they work together as part of continuous integrated workflow. It actually starts with ARP4754, which defines the system architecture and allocates function across systems. Then ARP4761 comes in to assess safety risks based on that architecture. The output from safety analysis, like safety objectives and integrity levels, feeds back into the system design as specific safety requirements. And finally, those requirements are then validated, verified, and ultimately certified. And actually, here's the key. This isn't a one-time process. It's iterative, repeated throughout the program lifecycle to make sure that design and safety evolve together every step of the way. Who should know these standards? ARP4754 and 4761 aren't just for safety experts. They're essential for everyone involved in aircraft system development. That should include system and safety engineers, system architectures, certification and quality teams, and of course regulatory authorities like USA and FAA. This standard actually provides a shared language that helps all stakeholders stay aligned from concept to certification. In the next part, we'll break down how safety and system planning actually work step by step, from risk analysis to building a solid safety case, all with real-world context. Stick around, there's a lot more to explore.